All
All right, looks like we still have people trickling in, so as usual, we'll go ahead and wait a minute to get started. But as always, Jeff McCartney's here with me today, and he will be there to answer scene in random directions, all the different areas. And when these rays come into contact with either a material or an environment, it's going to collect information about that material, its color, whether it's reflective, whether it's refractive, all sorts of information, and then it's going to return that back to that individual pixel. And that's what's going to determine its final shade. So if you set your samples to 16 as they're set here, essentially for every single pixel in this image, it's going to send out 16 rays just like this. And we have an image that is 1281 by 637, so you multiply those two. So if we do 1281 times 637, we have a total of 815,997 pixels in our image. So for every single one of those pixels, 16 rays are going to be shot out. So you can see there's a lot of calculation that goes into this when you're increasing the samples number. So if you multiply that times 16, these are how many calculations we have with just one ray bounce for that entire image. Okay, so if you decide to up that to 32 samples, then you get even more rays. Okay, so it's going to collect even more information about this pixel surrounding environment. And if you go to 64, you get even more. Okay, so what are samples good for? Let's